if you go with a pie chart, if you Google it, you'll find that at least 70-75% generation of our power in our country in the, till today, till 2025, based on coal. Efficiency of the power transmission is again very, very poor, not because of use of aluminum conductor, because of deregulation environment. You know what is deregulation? Deregulation means you are open the power in the open market economy, and all the customers try to extract the power from the cheapest alternator, and hence the efficiency of the power transmission stake is very difficult, and the efficiency is going down very, very, very fast rate. Almost zero customer participation. Nowadays, the kind of energy meter we use in your house, I mean the digital energy meter, the static meter that does not serve the purpose, we cannot communicate to the service provider. All the information comes from the generation side. Okay, you pay the bill at the end of this month. That is the only communication. So almost zero customer participation in a traditional power system, because we do not have the smart meter. Until and unless we install the smart meter by digital meter, by static meter, by advanced metering system, we cannot go for the by two-way communications. And another important is in case of a state utility, I mean Bengal state or Jharkhand state or Odisha state, I'm not talking about the private players like Calcutta Electric Supply, Adani, Best Power, Tata and all that. I'm talking about the state utility, their low billing and collecting efficiency, again a question mark. So these are the issues in the traditional power system. So we have to jump to a renewable energy. But before going into this renewable energy, the important aspect of renewable energy, we have to say in a very layman's language, in a very simple language, so that all the audience, those who are attending this program, will be able to understand. Most of the energy, just now I said, that is a coal-based. Even I am delivering a lecture through my internet and this laptop, and laptop is already in the charge state. This power I am taking from CSC, and this power from CSC is coming by burning coal. So by burning coal, I am conducting a FDP. But what is the difficulty with this burning coal? Forget about the technical issues. Apart from technical issues, other issues are very, very important. That is, this coal is a finite quantity. Our earth is finite. Our minds are finite. Therefore, the coal is finite in nature. And the way we are using the coals nowadays, 70% power we are extracting for our utilization. So gradually, this coal is gradually depleting. We are finishing our reserve, coal reserve, oil reserve, diesel reserve gradually. This is one important aspect. This is a finite thing, and gradually it is being depleted. What is the second part of this fuel-based energy? It is highly polluted. It emits a lot of greenhouse gases. It gives huge amount of carbon footprint to this earth. And we know in almost in every alternative year, there is a convention. I mean, this kind of that the international convention. I can say in 2015 there is a Paris Convention, and if I'm not wrong, head of 176 countries, including the previous president Joe Biden, our Prime Minister Modi ji, they all attended, and the target is we have to reduce this power. We have to reduce these greenhouse gases, hook or by crook, for our next future generation. So if this is the scenario, we cannot burn the coal. And from there, the concept has come net zero, net metering. Those are the new concepts that come. So if these are the scenarios, we have to find an alternative, because we cannot use this fuel, coal and diesel-based generation for a longer period of time. We have to find an alternative, and that alternative is nothing but renewable energy. Now, what are the renewable energies? The renewable energies are solar energy, which is coming from the sun, wind energy, which is coming from the wind, geothermal energy, which is coming from the deep part of the earth, geothermal energy, tidal energy, wave energy, like wind and sun. Again, there is a huge amount of energy is available in the air, hydrogen fuel, another kind of fuel, like coal. So that kind of energy is available. But we have to think in our country's perspective, maybe geothermal is available in USA, but in our country, geothermal is not available. We fully depend on solar energy and wind energy. Now, what is solar energy? Can you tell me what is the inertia of solar energy? I said in FDP there must be an interaction. Government wants it. What is the inertial level of sun's energy? Anyone from your end? Anyone can answer it? What is the inertia of solar energy? Any idea? No. No issue, no problem. Solar generation is basically DC generation, no rotating parts, and therefore the inertia of the solar generation is completely zero. This is one important issue, technical issue. The inertia of solar generation or sun's power is absolutely zero. If we talk about wind power, that windmill rotates in the tune of 8 to 9 RPM. So there is a small amount of inertia available. Now we have to understand, sir, what you are talking about inertia in solar energy. The thing I'm talking, this inertia possibly we all have learned in our class 9th standard of physics what Sir Isaac Newton said us. We are into a traditional grade. It's a really big issue nowadays. So let me read out what is inertia, possibly no, but let me tell you, let us again recapitulate what is inertia and how to relate with the power system. The law of inertia states that an object will remain at rest or continue moving at a constant velocity in a straight line, not necessarily a straight line. If it is a reclinear motion straight line, but in case of a power system, it is a rotational inertia, is a half I omega square, unless acted upon by an external force. In simple words, things like to keep doing what they are already doing. This law is sometimes called Newton's first law of motion and formed the foundation for understanding force, motion, and acceleration in physics. Inertia definition finally become it is the tendency of an object to resist changes in its state of motion. And this point, it is the tendency of an object to resist changes in its state of motion. We are trying to extract these characteristics, this feature from the synchronous generator, and I'll give an example in my next few slides how you are trying to extract this concept, Newton concept, in our power system synchronous generator. And another important, hey, now am I visible or some problem is there in the presentation again? Hello?
No, sir, you are audible. I have a question, sir.
Yeah, definitely. I like it because I am involved with this AICT auto issues and they want your recording mode, I guess. This kind of presentation should be interactive type with the budding researcher, budding faculties and this. Otherwise, they are talking involved with their committee. It is a kind of a ghanta khanek shumon, somebody is discussing, and this is interview, you are just enjoying or sleeping. Because they want it. I also want as a senior teacher of IST, I always tell, let it be interactive. In 1 hour deliberation, 20-25 minutes question, the questions might be wrong. Let it come from your side. Then this auto ICT, they'll give another FDP. Otherwise, it's not a one-way traffic. Somebody will just go on taking, and the other side, they are simply sipping, putting their audio and video. Nobody knows what that they're doing. I cannot see you also. So you must interact. And when you interact, don't bother. Whatever the thing comes in your back of the mind, just ask me. Please go ahead.
Okay, sir. Actually, we
But
know
before that,
that the
before that,
inertia is equal to the mass. Okay. So light means photon have do not any mass. So the inertia of photon is proportional to its energy or anything other.
no. Photon, we are not talking in terms of photon and that physics. Photon, we are least bothered. If we put coal to my plug, I will not get the power. I'm not talking about coal. I'm talking about coal-based power station. I'm talking about P, V, reactive power, delta power factor. Similarly, we're not talking about photon. Photon is coming. We are not putting, it is falling to the solar panel. Basically, it is crystalline silicon kind till 98% not in our country, across globe. And finally, they are converting because of the bandwidth and the physics phenomena, they're converting to electrical energy.
Yes, sir.
And we have come to the output. We are not thinking about photon, we are not thinking about the coal, chemical energy stored inside it. We are not thinking that. Let us come to the output. We are dealing with the electrical energy. We are converting that photon energy with the help of a photovoltaic solar. And that energy is a DC energy, is a DC power. There is a plus and minus. There is no rotation. In case of a DC energy, there is no rotation. In a solar panel, there is no rotating parts. So the zero inertia is available. And that is the thing I'll try to make you understand in my delivery. You got my point? How this inertia is detrimental in every seminar. We are all talking about renewable energy, but penetrating renewable energy is a Herculean task, is not a challenge. And we have to wait for another 500 years for 100% renewable energy grid. We are all talking by 2070 net zero. Okay, my age is 65. I'm not going to live up to 2070, but in 2070, 100% is not feasible. 20% base load should come from the fuel or from other sources. Otherwise, we cannot control the system. Your control will be beyond your control again. So anyway, let me come to the topic and then you'll be able to understand. Anyway, again, that Newton said the meaning of inertia is directly related to an object mass. What you wanted to mean. A heavier object is a harder to start and stop, and harder to stop also, moving compared to a lighter one. This idea is crucial, not just in science of classrooms like law of inertia class 9 or class 11, but also in power systems too. But how? This I will try to explain with few simple mathematics. Maybe in the next slide, yeah. Before coming to the mathematics, now let me tell what is power system inertia. That is general inertia, what we have studied in 9th and 11th standard physics. What is power system inertia? How does this rotational inertia, here the rotational inertia is half omega square. This half omega square, it is coming from every alternator. It trying to balance the sudden load which is coming to the system on a temporary basis. It is not the permanent solution. It is for only few seconds, for 9 or 10 seconds. Here I can put you a question. Do you know what is the ramp rate or rate of change of frequency level, ROCOF, in our country? Any idea from your end? Not globally. Our national figure? Any idea? What is the ROCOF value combining all the national grids of India? The average value? 6 seconds. 6 seconds. But if you use purely coal-based power system, it is generally 10 to 12 seconds. If you go for a completely renewable energy kind of system, solar-based, not the wind based, and it is say 0.1 millisecond. That's the difficulty. That is the difficulty if we go for the renewable energy. Anyway, I'll come later on. So that's the rotational inertia balance. How inertia is related to the group characteristics, that I'm not going to teach you. You all know what is group characteristics in an alternator, in a synchronous generator. And if you forget, I wrote the definition also. Group is defined as a percentage change in speed required for 100% governor action. And in case of a synchronous generator, alternator, the ramp rate is very slow. And that's a plus point for us. Because of the ramp rate is slow, in case of a synchronous generator and alternator, it gives a smooth control, rather soothing control, seamless control in a power system. Next. Now let me ask you, now the slides are changing. Can you see my slides?
Yes, sir.
Oh, then now perfect. Yes, now I think now I'm operating my laptop with the data, not with the Wi-Fi. So data is much more stronger than the Wi-Fi now. So I'm using through my mobile. I do not know. I have connected to my mobile, Redmi, and with that I am now managing the scenario. So now power balance equation. What is happening in a purely coal-based or diesel-based or nuclear-based power station? Let's see. We are bringing water from the water body, maybe river or lake. We are boiling that water, bringing that steam to a dryness factor 1, because in my biodata you have read out, I worked in a captive power plant in Durgapur steel plant and 4 years for 9 months. In Durgapur, we are having 2 units, 62 into 5. Now this is under NTPC. And during that time, I mean, I'm talking about 1984, 41 years back, that time, the poly, that is a poly shortage in power system. Now it is under NTPC, not under Steel Authority of India Limited. So we used to take water from Damodar River that is located in your Durgapur only. So that steam we are trying to put by opening the throttle valve, injecting to the turbine blades. What was the initial state of the turbine or turbine blades? 0. Turbine was not rotating. Turbine means turbine blades are not rotating. Initially, in its rest. This is as per Newton's law. Until and unless some force comes, the force has come from the injected steam. Now, blade starts rotating. Turbine starts rotating. Once turbine starts rotating, the turbine shaft is directly coupled to the alternator rotors. If it rotates, the alternator rotor rotates. In a alternator rotor, we have injected DC field, and in the stator, the closed conductors are there, and as per Faraday's law of electromagnetic induction, voltage is getting induced. Voltage is getting induced. This is the thing happening, very simple thing. But the way I told, this is not the thing. If you have a look at captive power plant or your DTPS, Damodar Thermal, I mean, no, DTPS means Durgapur Thermal Power Station. The way I explained in 1 minute, it's not that. It's a hell of a process is going on in DTPS and DPL. So that's a thermal power plant. But what is happening in mechanical power side, input power comes from the turbine to rotate the rotor. Try to understand, and then only able to understand the renewable energy and its challenges. Some amount of input power is utilized to rotate the rotor and maintain the desired frequency. In our country, the desired frequency is 50 cycle per second, 50 Hz in India. If you talk about USA, that is 60 Hz. And rest power is going for feeding to the customers. Again, there are 3 types of customers. Constant power load customers, constant impedance load type of customer, and constant current load type of customers. I'm not talking commercial customer, industrial customer, residential customer. I'm not talking from that economic point of view, not from consumption point of view. I'm talking from the load characteristics point of view, from technical point of view. These are mostly the customers are constant power load. So for simplicity's sake, I am considering Our load is constant power load, and let us consider it an ideal one. Now let us go to the next slide. Try to follow this slide very carefully. Example. Before going to mechanical power, in my previous slide, let me ask you a very basic question to you. In electrical power, I told if just obey Ohm's law, and in rotor we are injecting DC power, then Faraday's law of electromagnetic induction is bound to occur. Now I want to know one simple thing from you, just for curiosity's sake. Who has written Faraday's law? Any idea from your end? But of course, I'm not putting this question to the faculty member, those who are present, the budding researchers and other members, other esteemed members who are listening. Who has written Faraday's law? In 99.99% cases, the answer is, sir, Faraday has written Faraday's law. That's what is Faraday's law. As because Ampere has written his law, that's what is Ampere's law. Ohm has written his law, is Ohm's law. So why you are putting this question, Faraday's law has written? But my answer is, Faraday has not written his law. He was illiterate. He does not know how to write A, B, C, D. He was a bookbinder, but like us, he does not have any 220 papers, so many PhD producers. He was a big binder, but his brain was trillion times better than Professor C.K. Chandu. He gave the idea, but somebody wrote that law. Because he was a bookbinder, he doesn't know how to write letters and law. Any idea from your end? Where given? I know 99.99%, even the faculty membership, they do not know. They know that Faraday's law means Faraday's written. But electrical, but the history of science is telling Maxwell has written that law. We'll give you this one. Hello. আমি মিটিং এ রয়েছি, আমি একটা ক্লাস নিচ্ছি, লেকচার, আপনারা চলে আসুন, এসে একটু ওয়েট করুন আর কি, আমি একটা ক্লাস নিচ্ছি, ঠিক আছে? আমার 7:15 ক্লাস শেষ হবে। হ্যাঁ, তো the answer is, let me tell you, you just know this is very good information. We do mistake. The Faraday's law is written by Faraday, not that. It is written by Maxwell's. Faraday's law, Faraday gave the idea because he did not know how to write ABCD, completely fully illiterate, but the idea wrote by Maxwell. So in other way around, it is Maxwell's law. So that law will apply and will get the voltage. Now let me go with the simple mathematics. In simple arithmetic we are going. Mechanical power 500 megawatt. Rotational power, I mean the inertia, rotational inertia half omega square. Let us consider in a very random way 50 megawatt. But this is not a real data. Let me tell you, don't get confused. In a real sense, it's not that 10% of the energy, input energy gets consumed by the turbine. It is not that. Just for simplicity sake, to make you understand very, very clearly, I have considered 50 megawatt. It might be 3 to 4 megawatt only. 50 megawatt, just for example's sake. So for 50 megawatt, where from we are getting RPM? We are getting RPM from turbine. And if we put N is equal to 120 F by P, depending on the number of poles, we will able to calculate frequency, and that is coming 50 cycle per second or 50 hertz. So for 50 megawatt, we are getting 50 hertz. So simple mathematics, to produce 1 cycle per second, the turbine is eating 1 megawatt power. So 500 megawatt is the input. To produce 1 cycle per second, the turbine is eating 1 megawatt power, and the rest 450 megawatt is the pure electrical power, is going to the constant power load. This is the ideal situation and balanced situation when we are receiving 50 hertz in our load end. But this is a story. In real life, in ground reality, in practice, we never get exactly 50 hertz. We get slightly below 50 or slightly more than the 50 hertz. That is reality. Because Load is continuously variable in nature. So let us go with a case study 1. So mechanical power, we are giving 500 megawatt. You are not changing with this 500. Suddenly, in the electrical power side, 2 megawatt has come. Suddenly, without any intimation, without any information, suddenly this 2 megawatt power has come. So what is the electrical load demand as a constant power load? 450 plus 52 megawatt. And as a customer, we are rigid. We want it. We are not going to sacrifice where from this 2 megawatt will come. As consumers, as customer, we need 2 megawatt and we need it for 52. But mechanical power is 500 megawatt. So what we have to do? Mechanical power means boiler, turbine, not turbine, boiler. They have to produce more steam to produce more 2 megawatt to send it. But it will take half an hour time. 2 megawatt will not wait for that. We need 2 megawatt in a fraction of a second. But mechanical power means it is coming from the boiler, it is coming from the boiler tube, then throttle valve. These are all mechanical devices. That time constant is very, very high. Tau. Tau is very, very high. So within a fraction of a second, within 1 second, within millisecond, they cannot produce 2 megawatt extra. So mechanical power side is again rigid. They cannot produce 2 megawatt extra in 1 millisecond because they need a process. So who will help us? The turbine. Turbine is the only kind-hearted fellow in this system. He told that I am having 50 megawatt power as a rotational inertia, I omega square. I do not have electrical energy, I do not have the mechanical energy, but I have the rotational energy. Half omega square is with me. I will give you 2 megawatt immediately if you need it. So he is a kind-hearted fellow. This turbine will immediately give 2 megawatt in a 5 or 6 seconds, not 5 or 6 seconds rather. For a pure thermal power plant, it will take 10 to 12 seconds. 10 to 12 seconds. But our country's average value is 6 seconds by putting renewable energy as on latest statistics. It's very latest statistics. November 2025 value is 6 seconds. So from 6 seconds is telling how much renewable energy you have given in the system, almost 50% kind of thing in the western part of India. The second will tell you how much renewable energy you are trying to give into the system. On an average 10-11 seconds for that. So now 2 megawatt is now converting to electrical energy from the rotational energy. From the rotational energy. হ্যাঁ অমৃতেন্দু, আমি একটা লেকচারে রয়েছে, আমি তোমাকে চাবিটা দিচ্ছি, তুমি খুলে বসো, আমি আসছি 1 সেকেন্ড। হ্যাঁ হ্যাঁ আচ্ছা ঠিক আছে, ঠিক আছে, ছেড়ে কাজটা হবে না, আমি একটা কাজ নিয়ে পরে করবো, ঠিক আছে? তো I'm having another important meeting after 15 minutes. So am I clear to you what I'm trying to make you understand with very simple data? Is it clear to you? This 2 megawatt is coming from I omega square, not from the steam, and we are supplying and the customers are quite happy. But we have sacrificed because of this 2 megawatt, now 48 megawatt is available. 48 megawatt is available and the frequency has become 48 hertz. But we never allow 48 hertz in a real system. This is just a mere example. Let me go to the next slide. Again, case 2, mechanical power is 500 megawatt, that is rigid. In the electrical side, earlier 450 megawatt are there. Suddenly 2 megawatt has gone off from the system, thrown off from the system. Suddenly CSC had withdrawn power from the Sipur area. My power has gone off. So Wi-Fi has cut off and FDP is closed. Suddenly, without any intimation, when they thrown off the power, it happens because it might be a transient fault, it might be any kind of fluctuations, it may be kind of cascading failure in a device, maybe some equipment failure. There are a lot of thousands and one reasons behind it for a power failure. Suddenly 2 megawatt is gone, 448 megawatt. So who will now consume this 2 megawatt? Boiler will not ready to consume. You do not require perfect, but I will go on producing 500. You do not require, that's okay. You need 448. I cannot stop my generation. I cannot reduce my generation 2 megawatt within a second or within 10 seconds. I will take half an hour time for that. So again, that kind-hearted fellow turbine is there. Turbine will, okay, I was rotating in 3000 RPM. I will consume this additional 2 megawatt. I will rotate with faster. So present frequency is 52 cycle per second. This is just an example, say, not in reality. In reality, the frequency tolerance band is 49.5 to 50.5. But this is not exact. Because of the smart grid, we're trying to tighten the frequency band again. Now our frequency band is generally 49.5 to 50.5, but nowadays, because of huge amount of nonlinear load available to the consumers, we're trying to tighten the frequency band gradually. And that is only possible with the help of smart grid and smart metering. So this is the scenario. So imagine, now you try to think, if we put renewable energy into the traditional grid, say solar energy, because our countries in the western part of India, huge insulation is there, huge irradiance is there, huge sun's power is there. So if we use renewable energy to the grid, and if there is no rotating part, we will manage this 2 megawatt if there is a sudden demand or sudden thrown up from the system. This synchronous generator managed it because of the turbine. Solar generation cannot help you. Turbine generator cannot help you in this way if there is a certain demand, because they do not have the inertia. But of course, I'll not get that much amount of time to explain you. Nowadays, a lot of virtual power plant, virtual inertia, and solar I mean the synthetic inertia is available. Hats up to power electronics people. They have developed a lot of storage solutions are available. We can mitigate this problem up to a certain extent, of course, with renewable energy. These are all I'm not going to show. What is the impact of inertia on power system? Let me try to sum. The impact of inertia in the power system is this: if there is a sudden demand of power or deficit demand of power or surplus of power, then this rotational inertia will take care of, and within 9 or 10 seconds for the time being, the power system will be survived. In power system engineers, in a real engineers, they call it as a golden time. That is a golden time. This is not there in a textbook, but the real power engineer, those who are working in a power system, those who are in ERLDC, they say this 10 seconds time, 11 seconds time, 12 seconds time is a golden time for the power system. Within these 10 seconds, if you are able to take the action and turbine will take action, the system will be survived. Otherwise, it will go out of gear, a complete blackout or duckout. And to make you understand this thing in a very simple language, rather in a simpler and layman's language, I can give an analogy of heart attack. If any human being gets attacked, heart attack, if he faces an heart attack, if you can take that patient to the doctor's chamber within half an hour, there is a possibility, or within 1 hour, there is a possibility that patient will be survived. Because the moment heart gets attacked, the muscle starts deteriorating immediately. But if you delay for 3 hours, 4 hours, 5 years, if you take the patient after 6 hours to a doctor's chamber or nursing hospital, there is a possibility, least possibility of survival. Because in the meantime, the heart got already damaged, muscles had already got damaged, and God has gifted a small pump. In our residential life, we use Tulu pump, and God has given a small Tulu pump inside our body. That is the heart. That pump is continuously working for blood in and blood out through the veins. So that will be stopped because of the muscles deteriorations. So first half an hour, first 1 hour, it's called the golden time or golden hour for the heart attack patient. Similarly, first 9 seconds, first 10 seconds, immediately 10 seconds only, is the only golden hour, golden time for power system revival because of the turbine. Imagine if it is a renewable energy, where from this 10 seconds will get? Who will give that rotation? And obviously, we are inviting the power failure and the issue with the renewable energy. So these are the issues with this. So now the question is, then sir, what will happen? You are talking about renewable energy with so many difficulties. We will not get any time to revive. There is no rotation. What will do? The answer is yes, we have to. In 1970, when there is a crisis of oil, we started thinking renewable energy, and we started thinking in that way. Renewable energy might be the alternative energy for coal. But in 2025, again, the same engineers, same technologies, same academia saying there is no alternative of alternatives of energy. We have to accept some energy. We have to find some other prescription. We have to find some kind of solution. We'll use renewable energy. We have to create kind of inertia virtually, not through this I omega square, so that the grid should be stable from frequency point of view, and there is no questions of rate of change of frequency. So what are the basic challenges of renewable energy? The first challenge of renewable energy is hard to forecast, and tied to meteorological forecast. Sometimes backcasts are very difficult to forecast. Of course, nowadays a lot of forecasting softwares are available. We can forecast very nicely, but all the forecasting softwares nowadays are completely tied and connected to the meteorological parameters. If that meteorological parameters are erratic, is not error free, then your forecasting of that will be little challenging. What I mean from this point, say, try to understand, we are extracting 500 megawatt from one solar panel generation. Say your institution is having, say, 100 kilowatt generation and 100 kilowatt generation in your institution. From solar panel on the rooftop panel, you are extracting 100. Suddenly, you do not know the cloud has come, and the cloud is staying on that solar panel for half an hour. Then what will happen? Because of diffusion of light, you are early receiving 100 megawatt from the 100 kilowatt from that panel. Now you will receive only 10 kilowatt. So 90 kilowatt has gone from the system. And your machine lab examination, that FDP program is going through the internet, everything will collapse and total failure. Suddenly, nobody knows it. So the ramp down rate of the renewable energy is very, very high, in the tune of 0 second, or 0 second is a mathematical second time, and very difficult. Locational dependency is very, very important. Offshore and desert. Hello? Somebody is speaking inside. No, you, the organizing member, asked them to stop their audio and video both. I think somebody is gossiping inside it. Locational dependence, because everything will come in your recording mode. Locational dependence, offshore and deserts. Non-synchronous technology. Renewable energy is not the synchronous based. Basically, it is inverter-based generation, IBG. No rotation. Connected through power electronics, because if you want to connect this DC power to the classical grid where AC is available, you have to use inverter. An inverter is nothing but a power electronic device. Power electronic device is nothing but high frequency switching circuits. High frequency switching circuit is nothing. Normal sinusoidal wave will be converted to a distorted wave with a lot of harmonics, interharmonics, and subharmonics. So these are the issues with the renewable energy. But we are all talking about renewable energy. We will put it by 2030, you'll get by 2047, Viksit Bharat, all this. Okay, perfect. But real-time implementation is a little difficult, and scientists are working in that direction and unable to support traditional grid services. So these are in fact, the challenges. My topic was a little challenges of the renewable energy, and that challenges we have to cope up for integrating to the smart grid. So increasing penetration of intermittent renewable energy is always intermittent, stochastic in behavior. We do not know when it will be available because wind will blow according to its will. Sun will give its irradiance according to his wish. I cannot demand sun, you give your irradiance just now at 7 o'clock in the night. No chance. Sun will give its irradiance according to his will. Human being, no industry, no Ambani, no Modiji can dictate sun. You give power now. So they're highly intermittent in behavior. But the plus point of sun and wind is they're not going to come. They're not come. They're not extend their hand to take the money. Sun will not. Okay, I'm giving this much amount of solar energy. Please pay money to me. No chance. What happens to coal? So intermittent renewable energy generation brings more challenges and introduces additional uncertainties in the power system. So lot of challenges, lots and lots will introduce if we put renewable energy. Of course, technologists are working. This is the system inertia, what I wanted to mean. And this system inertia, let me tell you, as time is limited, this system inertia is now become a time variant system inertia because from sun's energy, inertia is 0. From synchronous generator, this is 3000 RPM. From wind, it is 9 RPM. From geothermal, it is in the tune of again 3000 RPM. So if you try to connect all kinds of renewable energy in a particular grid, then the inertia has become time variant in nature. That is again a difficult decision, another challenge. The inertia, what we used to calculate in a static fashion by simple mathematics, I omega square, now it is not possible. You need the adaptive control or some kind of sensing device by which we can able to measure this time variant inertia. A second is you need GPS, you need some help of satellite, you need synchrophasor, you need PMU and all that to measure that inertia. So it's very difficult to measure that inertia and the critical value. With this slide, I'll finish my delivery now. I am having one important meeting just after these. People are waiting outside. In the left side, you have a look. The system extension. System extension in the means gradual load is increasing, including this renewable load, the prosumer, those who are generating and consuming both, the net metering concept, and the wind energy you are penetrating to. So that way the system is getting extended day by day. System extension means more complexity is coming. So and more system extension means another important point, the sort of circuit ratio gets down. That is the important issue. I am not going to explain what is short circuit, strength of the circuit. The short circuit becomes very, very poor in case of energy penetration. Another negative part. Weather phenomena. Almost in every May month, we get a super cyclonic storm in India. Amphan, this pan, that pan. Few days back, the Mantha. That the super cyclonic weather phenomena. There's a huge amount of climate change. So a lot of issues are coming. That impacts a lot to the power system. And there the question comes, the resiliency of the power system. The system should be highly resilient. That's a new research topic nowadays. A lot of research are doing resiliency of the power system because of weather phenomena. And my two research scholars have done resiliency under these weather phenomena, collecting data from Amban, and they submitted their PhD. And large power flows, that is very, very important. Is huge because of the deregulation of the power system, deregulation. Because we try to operate the power system in a very competitive environment. It is not that the government utility as much power will give the subsidized price. It is not that. It is a kind of a power system means they are not the government utility, they are the service provider. They are providing the electricity. We have to pay the money or the. So there is a huge amount of competition between the private players. And when there is a competition among the private players, what happened to the customers? They will try to extract the power. They will try to suck the power from the cheapest alternator, from the cheapest generation site. And what is the cheapest generation? Of course, the solar energy. Sun will not take money from us. solar. So what happened? If there is a solar-based generation in the western part of India and in Calcutta, if you want to take power from that side, so particularly few specific transmission corridors will be congested. The way I'm saying it is not that, but it is difficult, but the lines will be very, very congested and some effects will become. And another important issue is the market rules in the deregulation. So, lot of negative aspects are coming, putting renewable energy into the smart grid in the left hand side. The right hand side, gradually you are decommissioning the rotating machine, means you are losing rotating inertia. Inverter based generation is coming into the picture. Because of that, decreases of inertia, a rate of change of frequency. In fact, I do not know whether you know it or not. Probably you know, you all faculty member know there is a Nadir point. Nadir Sahab wrote a very beautiful paper, and that paper is accepted by the global technologies. That is called the Nadir point. We can allow the fall of frequency of rate of change of fall of frequency to the Nadir point, either overshoot or undershoot. Will come, we allow up to the Nadir point. Short circuit power reduction takes place in case of a inverter bus generation. Deterministic frequency deviation is very, very important issue. Inter-area oscillations comes because of the one is a classical energy, other one is a renewable energy. Load behavior is completely changed nowadays. I can give an example of a load behavior. You will also accept this idea as an academia you're able to follow, even if you work in an industry level to idea. Last 5 or 6 years, we see a lot of totos on the road. In my area, Sipur area, in every lane, there are thousands and one totos. Toto and toto. Totos are more than the passengers. One toto is carrying only one passenger. There's so much competition among them. How the toto is running? Toto, in other way around, we can consider as an electrical vehicle. They operate on battery only. The people, the Toto owner or the driver, they go back, and in the evening time from 8 o'clock, they put their 4 batteries into charging. Imagine if there are 50 lakhs Toto in West Bengal, and if they're going to charge 4 batteries, so 50 lakhs into 4, 2 crores battery you are trying to charge, and that charging is basically a DC kind of charging. It's coming to the state utility and CSC agreed, and imagine how the load has behaved. What was there in not last 5 years back? And the people from ERLTC, CSC, they're not able to manage the grid after 8 p.m. So many charging, 2 crores batteries they put. Toto people, they do not know. They know electricity is available, I'll put into charger and that's all. But they do not know how they're changing the characteristics of the grid. 2 crores battery, charging load has come, and charging load no, is absolutely nonlinear. 100% nonlinear. So huge amount of area oscillations and all these kinds of things are coming, and that we have to handle it. For all these things, because of time constraint and time limitations, I will take 1 or 2 questions from you. This is Rokov. These are all mathematical models of Rokov, del P impedance, P load, if not by 2H. These are all not, I'm going into this mathematics part. This is Rokov, and we have filtered by the active filter. Which color? Yeah, green and orange. Orange without this filter, and with filter the green color. Rokov has come because of penetration of renewable energy. All renewable energy is responsible for this orange color. Imagine, you're all talking about renewable energy, but this is the effect of renewable energy. These are all. So this is interharmonics and harmonics kind of thing. So what I wanted to mean, or rather I want to finish by this, everything, whatever I have shared, the major prescription or solution of these kind of negative points of penetration of renewable energy in the smart grid is AI, artificial intelligence. Artificial intelligence in a true sense in a game changer in a renewable energy. There are a lot of benefits of artificial intelligence, optimized energy production. The profound impact of AI ensures maximum output from renewable, because this AI can handle trillion and trillion data. Even the normal computer, supercomputer cannot handle at the same time. So you need a powerful programming, powerful software tool, what we call as AI. And that AI able to handle up to certain extent if we use renewable energy as a source by managing, what should I say, demand side management, or demand response, by virtual power plant, by virtual inertia, by synthetic inertia, we can mitigate this issue up to certain. These are the possible solutions, weak grid, strength grid, AI, and all that. And the finally future directions is the integration of AI. Now, in fact, we are in the cross section of AI and classical power system. The integration of AI will continue to play. AI will continue to play a pivotal role in the transition to a sustainable energy future, supporting the global push towards carbon neutrality. What are the models you use for that? AI, the different kinds of AI you use: expert system, ELM, support vector machine, ANN, KNN, machine learning, deep learning, CNN, LSTM, ARIMA, PSO, advanced PSO, modified PSO, to name a few. Heuristic optimization technique to handle a more data, we go for the meta heuristic technique. There are a lot of actions, optimizing techniques are available and utilizing. But these are all discussions in theoretical level in FDP. But what we need as an engineer, call to action. We have to think seriously so that we can really implement in a power system. We can get the benefit of that. So embrace AI-driven innovations to lead the change in renewable energy transformation, ensuring a cleaner, more sustainable world for future generations. And this is all about my delivery. And thank you for your patience hearing. If you are having any questions from your end, you can ask me, or I leave this because some important meeting is there and people are waiting for me. Anything, if you want to ask me, you can ask me. I'm happy to answer that questions. Any vague questions, right? It doesn't matter. Anything it comes to your back of the mind, I'm ready to answer it. Any questions? No.
Participants, if you have any questions, you can
You
clear
can
your
ask,
doubt.
anyway, it may not be, it does not mean that I know the answer for all questions. If you do not put any question, if you do not any questions to, I am the happiest man from this end. You am free, I'm going. But in this kind of FDP seminar conference, we need questions from the audience. Then only it will be little interactive. 95 participants are there from there, but no questions. Anyway, this is all about from my end. And let me stop here. I am leaving with your due permissions.
Sir,
Because
just
another important meeting I have to attend now. People are waiting outside.
okay,
So,
sir. Just a minute, sir. Just give us a few minutes.
Uh-huh.
Sir, first of all, thank you, sir, for giving your
Okay, no
valuable
problem.
time from your busy schedule, sir. It was a wonderful session, and I hope our participants have enjoyed this session. And it was really interactive session, and I think our participants will be benefited by this session. Sir, I would like to just share a small token of appreciation from our
Okay, great.
side.
So, Swami, thank you so much.
Just a minute, sir.
I have accepted your request because you worked in the Durgapur steel plant for 4 years and 9 months, and NIT Durgapur National Institute of Technology, earlier RE College, 2 years and 2 months. So I have a special weakness to that Durgapur place. The moment the invitation came from Durgapur, I immediately agreed because I was a faculty of NIT Durgapur for a few years.
Okay, sir. Is the screen visible, sir?
No, screen is not visible. It is not
Okay.
visible. Okay, I accept your that the appreciation. Screen is not visible. That is the issue with the online. No, you are trying to show, but I am not able to see.
Okay, just
That issue is there. This is not the failure from your end. It's not the fault. It is not visible to me. But you are trying a lot to show me. This is
yes.
okay. I appreciate your gestures. So thank you all. And I am leaving now. We'll interact again later on. And my mail ID is Dr. Priyanka Dutt. If any question comes, I can answer in email too. So I'm leaving now. This is
Sir,
it.
if it is possible, can you share your PPT with our?
Yeah, that is, I'll share it, but you have to give 5 hours because tomorrow early in the morning I have to go to Delhi for Indo-France conference. So I'll come back on 23rd, 24th after that because I will be very busy for next 3 or 4 days.
Okay,
I
okay,
am
sir.
not going to carry laptop.
Sir, can you share your mail ID?
Huh? Mail
Can you
ID
share
is
your
with you, madam. No, I got the link means mail ID is with youth only. No, I got the link and that's why I have joined. Yeah, now I got it.
yes,
Swami
yes.
Vivekananda School of Diploma. Oh, very nice, very nice, very nice. Really appreciable, and I appreciate your gesture. Thank you so much. But one mistake is there in the certificate. My name is not Dr. Chandan Kumar Chandan.
For your
It should be Chandu. Chandan Kumar, CHNDAN should not be there in my surname. There is a mistake in the
Okay, sir.
my
We will rectify it and send
yeah,
you
yeah, that's okay.
through
You
mail.
rectify later on. Perfect. So I'm leaving now. Thank you so much.
Okay, sir. Thank
Okay.
you, sir. Thank you.
Participants, please stay with us. Our next session will start from 7:30 onwards.
হ্যাঁ করতে পারেন, অসুবিধার কিছু নেই।
Arnab sir, am I audible?
Yes sir, you are audible to me.
Thank you, sir. Participants, as we can see, our next expert speaker has already arrived in the online mode. So, without any delay, I think we should go on for our second session of the day because our first session has ended up a few minutes earlier. So, let's begin the session. So today we have among us Mr. Arnab Shah, who is going to enlighten us with his valuable knowledge on behalf of Electrical Engineering Department of Swami Vivekananda School of Diploma. We welcome you, sir, in the second session of this FDP program on energy and sustainability, sustainable development through advanced renewable energy technologies. Now, sir, with your due permission, I would like to read out your short biography, sir.
Okay, okay sir, carry on sir.
Okay. So, Mr. Chandan Kumar, so Mr. Arnav Shah has a 15 years experience as a maintenance engineer in DVC Major Thermal Power Station. He has received gold medal in his MTech on power electronics and devices from IIT Dhanbad. He has done his BTech from Jalpaiguri Government Engineering College, West Bengal. He has a paper publication in IEEE Calton on case study of failure of neutral flexible link and hexagonal bus header plate in palm connector of 210 megawatt generator and recommendation to prevent sensual error. So this is was a brief introduction of our next expert speaker. Sir, the session is yours.
Okay. Thank you, sir. Thank you very much for the introduction. First of all, a very good evening to all my esteemed participants. And I want to thank Vivekananda School of Diploma and team for giving me this opportunity. Today, I am going to discuss about my topic, enabling a renewable future with flexible thermal power plant and energy storage system. Now, before going directly to the slide, I would like to give a brief idea about my topic. What is it actually? We all know Indian power sector is going through a major transformation. Till now, most of the electricity, around 67%, which we are using, is come from coal-based thermal power station. But now we are shifting from coal to renewable energy, mainly because it is environmental friendly. But renewable energy has major drawbacks, such as it cannot support 24/7 power, just like thermal power plant. To make renewable energy available round the clock, we need storage system. But storage technology are still new in India. Only a few are commercially proven. So 100% renewable energy transition take a plenty of time. Till that time, thermal power plant cannot be replaced. But the problem with the thermal power plant is that they are mainly designed as a base load unit. What does it mean by base load unit? Means if a thermal power plant rated output capacity is 500 megawatt, it is designed for to produce 500 megawatt only. It is not designed to operate in any intermediate load between 0 to 500 megawatt. But integration of the renewable energy, thermal power plant need to change the load frequently as per green requirement. So existing thermal power plant need upgradation and modification to operate in flexible condition. My presentation is all about how to convert this traditional base thermal power plant into a flexible thermal power plant and basic idea about energy storage system that supports our renewable energy goal. Now, India wants to achieve net zero by 2070. To reach that milestone, our country set a goal for 2030. It's want to reduce its emission by 40% in respect of 2005. In this graph, you can see that around 76% of emissions share come from energy sector, mainly from fossil fuel-based thermal power plant. So that So we need to shift toward low carbon, zero emission renewable energy to reduce this emission quantity. And India has that potential. For that, Government of India plan to integrate 500 gigawatt of renewable energy by 2030 in our existing grid. And in 300 mega, among these 300 gigawatt is solar power, 140 gigawatt is wind power, and 60 gigawatt is hydropower. And we can see that on 2010, the installed renewable energy installed capacity is 63 gigawatt. And by 2025, it increases up to 242 gigawatt, around 400% increment in just 15 years. So we can achieve that 500 gigawatt goal very easily. In this world, nothing is perfect. So renewable energy is also not perfect. The major drawback of renewable energy is that it cannot produce electricity throughout the day. It is only available during a certain period of the day due to its dependency in the weather. Now, this curve actually shows the solar power plant output curve. And we can see that between 6 a.m. to 6 p.m. only the generation is available. And the generation is also not constant. It is varying with time. At noon, it is maximum. And at the evening, it is evening and morning, it is minimum. Also, this yellow curve, you see, this is the generation of a solar plant in a cloudy day or a rainy day. And we can see how much variation is there in the output of that power plant. So if we do not integrate solar power plant efficiently in the grid, it can lead grid instability or even grid failures. And this is not a theory. Actually, this thing happens. A recent grid failure occurred in Portugal and Spain in April 2025 due to a sudden fluctuation in solar energy. On that day, around 70% of Spain and Portugal electricity demand was being supplied by renewable energy, among which 59% is from solar. But a sudden dip in the solar power around greater than 50% within 5 minutes occurs due to cloud, and which causes the grid frequency to fall 50 to 49 hertz and lead to cascading tripping of the relays and cause grid failure. So as we moving toward 500 gigawatt of renewable energy, such fluctuation will become more common. So as the major shareholder in Indian energy mix, thermal power plant must become more flexible and capable of fast response to handle these fluctuations. Why flexibility is the key for thermal power plants? Now, here we see this curve is
Sir, sorry
represent.
to interrupt you, sir.
Okay, sir.
Sir, can you make it a slideshow mode?
Okay, it is not in slideshow mode, sir.
Yes,
Just a minute.
it is in presenter mode. I think the entire screen is visible on the
Okay.
presenter mode. It's just you can see on the
Okay.
left-hand corner. You can see
Ah,
on your screen. Use slideshow. On your screen on the left-hand side. Yes, sir. Now it's okay. It is in the slideshow mode now.
okay, now it's in the slideshow, no?
Yes, sir.
Okay.
Yes, sir. You can continue.
But slide is not changing actually. Just give me a second.
Okay, sir.
Now you can see the slide, sir.
Yes, sir.
Yes, sir. Okay. Now let's see this duck curve. Actually, duck curve is nothing but a one-day demand versus generation curve. And this red line represents the demand of the grid, means load of the grid. And we all know for a stable operation of grid, always demand is equal to generation, means load is equal to generation, then only the frequency remain constant. So here the black curve is the generation from, here this black curve is the generation from the thermal power units. And this yellow curve is generation from the solar power plants. And this green is from hydropower station. Now, during the night time, there is no solar power generation available. So thermal power has to run at its peak. And during the daytime, as soon as the sun rises, solar power start to deliver power in the grid. And to accommodate this power, thermal power plant need to bring down its power output gradually. And again, when the sun start to set, the solar power output is also decreasing, and the thermal power need to increase their output accordingly. And in that way, we can make our grid stable. So this base load thermal power station need to be flexible in order to support the renewable energy integration, basically the solar energy integration. Now scheduling. What is scheduling actually? Suppose today I set my own thermal power plant, say 500 megawatt thermal power plant. So as a owner, I obviously want to run my thermal power plant at 500 megawatt. But if all the owner want to run their thermal power plant at their maximum capacity, then there is a big chaos in the grid. Here, the load dispatch center comes. They control the grid. Actually, they control the grid. They ask all the generating station to declare how much power they can generate for the next day, and ask the distribution company how much load they expect for the next day. Based on this information, load dispatch center give instructions to each generating station how much power they are allowed to generate in each 15-minute block. This process is called scheduling. It is basically a permit to generate. Actually, generating station cannot generate power as per their own. It has to follow this load dispatch center instruction. And how this scheduling is done? Each generator, first one day ahead, each generator submits its declared capacity to the load dispatch center, and each state distribution company, which is DISCOM, just as WB distribution, West Bengal distribution company, Rajasthan distribution company, all these distribution company forecast their expected demand for the next day. And they submitted this to the regional load dispatch center. Now the load dispatch center compared the total demand and the available generation from all the sources. And this scheduling done on merit basis. What is merit basis? Renewable energy are put in the highest merit because first priority gives to solar and wind to generate. First chance is given to the solar and wind energy actually. After that allocation, load to the solar and wind energy, if any demand remains, it's allocated to the hydro because all these are clean energy. And the remaining load is then supplied by a cheapest thermal power plant. And after that, if any demand is there, then only high cost thermal power plant are scheduled to meet that demand. And this plant has, and all the generating plant has to operate it according to this instruction of load dispatch center. And the actual generation of the all generating station are recorded in the SCADA data. And if they deviate from their instruction given by the load dispatch center, then a penalty is they are penalized. So we are bound to generate as per load dispatch center. So our thermal power plant need to be flexible to operate any load as per load dispatch center demand. Now, what is flexibilization of thermal power plant? Traditionally, coal-based power plants were designed to run at a constant load known as base load. They cannot change load quickly. But today, because India is adding a large amount of solar and wind power, the grid needs fast response power plant. Solar and wind are variable. They change with weather. So the thermal plant must adjust its own output quickly to balance the grid. Flexibilization means upgrading the existing baseload thermal power plant to make them smart, fast, and responsive, so they can support renewable energy and keep the grid stable. In simple words, variable solar and wind need support from flexible thermal power plant. So why we are stressing only the thermal generating unit? Just look at this picture. Assume this jar represent the Indian electricity grid, which has a fixed capacity, a fixed space, which is equivalent to the load or demand of electricity, and this space is occupied by different power generation. The maximum share is coal-based power plant, which is around 67%. And there is 12% hydro, which is already a clean energy, 3% nuclear, and other is around 3%, which is gas or diesel based. So now when we want to introduce more clean energies, more solar and wind energy into this grid, we need to create some space inside the jar. So how we can create the space? There is only one practical option. Thermal power must reduce its share temporarily to make the room for solar and wind during the daytime, because thermal has the maximum share. Thermal is the major source of emission, and other source, hydro, nuclear, they are already clean, and the gas is very negligible share, which